Jimmy on the beat, boy.
Okay, boomer. Whatever you say, boomer. Okay, boomer. Yeah, boomer. Whatever you say, boomer. Okay, boomer. Yeah, boomer. Whatever you say, boomer. Okay, boomer. Whatever you say, okie dokie, boomer. BOOMER, please your dusty mood, don't vibe with me. You are old and so therefore I must say 10 for dinosaur 8. Okay, boomer. Whatever you say, boomer. Okay, boomer. Whatever you say, boomer. Okay, boomer. Whatever you say, boomer. Okay, boomer.
Jimmy on
Okie
the
dokie,
beat, boy.
boomer.
Okay, so we've just gotten the data from NASA from their January flyover of Greenland and Antarctica, and this plot for the land ice in Antarctica and Greenland only shows the past 4 years of data, and that is the GRACE follow-on era from 2018 to 2022. NASA had a change of satellites, and the data from the new satellites only came online in late 2018, which is why we don't have January data from GRACE FO. So if you compare these January net losses, you see that Antarctica posted net losses for the first 3 years, 2019 to 2021, but in 2022 it went the other way, so it was a net gain of ice in Antarctica in January this year. While for Greenland it's different, it's like been all over the place, and this year posted a small gain. It's the smallest of the two gains, but it's kind of average for the 4 years. So because of the Antarctic gain in January, you will see smaller numbers on the next slide. Smaller losses for the multi-year averages. That's just the way these numbers work. If you posted a huge loss, like double the size of these other losses, then you would also see the multi-year averages going down faster, most likely. So we'll be presenting this graph also for the coming months, so you will have a full year by the end of the year of the 2018 to 2022 net monthly losses or gains. So another point while we have this graph up is that in 2021 you had a January loss of about, say, 310 cubic kilometers, because cubic kilometers is the unit here, and that is approximately, like a daily loss for January of 10 cubic kilometers. Just keep that number in mind, because January, at least traditionally, has been the biggest ice loss month for Antarctica, and the numbers on the multi-year averages are usually around or below 1 cubic kilometer loss per day. So this is for the best month for melting 10 is sort of the absolute, the highest it can go for, just for a day-to-day, irrespective of any longer averages for months or years. So yeah, if you only look at the here and now and the day-to-day losses, 10 is sort of the statistical maximum that we've seen. Okay, so back to Antarctica down here, you see that the numbers are very, very low, and that's because of the latest data point being such a uncommon statistic for January. It usually posts a melt, but it posted again. But that doesn't mean that the multi-year averages are for loss are negative, because they are averaged over so many days, so many years, a decade in this case with the 10-year average. So the highest losses for the multi-year averages for Antarctica are at 0.5, that's half a cubic kilometer of ice. And you see the 3 to 1, the shortest multi-year averages. They are also very, very low, like 0.3 for 3 year and 0 for 2 and 1 year. And so that means that for January, at least, the latest data we have, the hypothesis that Antarctica is taking over and melting faster than Greenland doesn't hold up in this case, not yet anyway, because you see the 1, 3 and 2 year for Greenland are all higher than the same for Antarctica. And Greenland also posts a 0.8 daily loss for the 3-year average. Yeah, so you see some of these going down since last month, and some of them are going up, so it's kind of, yeah, I guess more of them are going down, so it's not the highest, most extreme melt season at the moment. But you do see that Greenland has a higher, the biggest daily loss from multi-year averages, 0.8, is higher than any of the same for Arctic sea ice. So that means we have put the land ice in motion, and many scientists argue that it's the sea ice melting first that is triggering the land ice to melt, and that seems plausible to me. So you set this monster in motion, and for the sea ice itself, it's kind of the same picture with not really being out of the low numbers. I think it's still going down. The melt is still going down for the multi-year averages so far, and you even see minus. It's net gain per day down here in the 6-year average. So what does this all mean for the elusive Blue Ocean event? We still have a 2037 date, that's the earliest one. That is for the 20-year average, which is falling at 0.7 cubic kilometers per day. Of course, averaged over 20 years, so it's a more stable graph to follow. It doesn't go so fast up and down as the shorter ones. But the brunt of the estimates for half-year ice-free ocean are in the late 2030s, and they usually say that the very first blue ocean event for a day or a week only, not a half year as we estimate here. It will be like 3 or 5 years before you have a full half year of no sea ice in the Arctic Ocean. So that means like 2035, maybe 2032 at the earliest for the statistically foreseeable estimates. Of course, the natural ups and downs of the Arctic and the climate system are less predictable. That means it can be, like any year in the near future. For the first blue ocean event in 3 million years, but if you go by longer term averages, it's like in the early 2030s for the short term, a week of no sea ice. Okay, so we're still looking like we're going into a prolonged La Nina event for this summer and autumn. That is like about 50% likely, I think it was. So maybe these low numbers will go on for a while, maybe not. Maybe there will be a turn when sea ice starts melting this spring. These numbers are related to February, so it's not this month. It's like last month. So we could still see a spring speed up of the Arctic sea ice melt, but only time will tell. Okay, bye.